Okay, so number 5 with 2 parts says, find the relative max or min of this function using the second derivative test. So on the AP exam, it's not going to say how to find the max or min. It won't say use the second derivative test. But in this video, we'll see why we actually have to in this case and how to do it. So let's proceed as we normally would to find relative extrema. Step 1, find the critical points of f of x. How do we do that? We set f prime of x equal to 0. This is where we find the roots of the derivative. Step 2, we're going to use a number line to see where f prime of x switches signs. Keeping in mind, if we have a relative max, that means f prime of x went from positive to negative. And if we have a relative min, it means that the derivative went from negative to positive. So the slopes were negative, and now they are positive, so the graph is increasing. Great. So let's deal with our first derivative. The derivative of 2 sine x is 2 cosine x. Derivative of x is 1, and the derivative of 1 disappears. Next step, we'll set this equal to 0. So solving for x, I get 2 cosine x equals negative 1. Dividing by 2, I get cosine x equals negative 1/2. And now to solve, I need to label this as x over r. And I know that cosine is negative where my x's are negatives because r is always positive. So where is x negative? Well, in quadrant 3, and in quadrant 2 actually, and in quadrant 3. However, notice over here it says only we want the values of x from 0 to pi. Well, this is 0, this is pi. So if we only want between 0 and 180, we're going to cancel out the bottom 2 quadrants. And we're only going to look at the x value in quadrant 2. Let's drop the perpendicular here. Our x is negative 1, our r is 2, meaning this is a 30, 60, 90 right triangle because the side lengths are 1, radical 3, and 2. Okay, finishing up. We're almost there. Since this is across the radical 3, that means our reference angle is 60 degrees. So if our reference angle is 60 degrees, that means this entire angle is 60 degrees less than 180 or 120 degrees. Now, degrees are fine except for they're asking us to deal in radians. So 120 degrees is the same as 2 times 60 degrees, which is 2 pi over 3. So remember, pi over 3 is 60 degrees, and we need that twice. Okay, so normally at this point, we would use our number line and plot our value here. So if that was the case, but notice that this is not a polynomial function like the ones we're used to. It doesn't say, for instance, like x minus 3 whole squared times x plus 5, in which case we would use the exponents to flip and keep. This is not a polynomial, it's a trigonometric function. So when we have problems like this, we'll use the second derivative test, and here's what the second derivative test says. So the first part of the second derivative test says, if your first derivative equals 0, what does that mean? It means that you have some sort of a horizontal tangent line. So it could be like this, or it could be like this. And the second derivative is greater than 0. So it's positive. Well, what does that mean? It means that you're concave up. So if both these things are true, you have a horizontal tangent line and you're concave up, so that means it'd be this part, then you have a relative minimum. That has to be true. So imagine your cup up and you have a horizontal tangent line, it means you have a relative minimum. So from our drawing, that makes intuitive sense. Here's the second half of the second derivative test. If I have a horizontal tangent line, so again, either of these cases, but also the second derivative is less than 0, so the second derivative is negative, meaning I'm concave down, then you must have a relative maximum. Your cup down, and at the horizontal tangent line, you would have the relative max there. So If that's the second derivative test, that means that we need to find the second derivative and figure out at 2 pi over 3, at this point right here, are we concave up or concave down? So let's erase this number line. It's not useful for us when we need the second derivative test. And let's label this our critical point. So our critical point is a potential extrema, a potential max or min. Let's see which it is. So the second derivative is going to be negative 2 sine x. Now, I want to know if my graph is concave up or concave down at this point. So we'll plug that in and see. Okay, so sine of 2 pi over 3, we can easily evaluate that because we've already drawn 120 degrees over here, and sine is y over r, so that'll be root 3 over 2. So that's negative 2 times root 3 over 2. The 2's will cancel, leaving me with negative root 3. So what I'm realizing is the second derivative at 2 pi over 3 is negative. That means that it's less than 0. That means that it's concave down. So you don't have to memorize the second derivative test. It's very, very intuitive. If it's concave down, go ahead and draw a quick sketch. If we're concave down, but in the first derivative, at that value, we equal 0, meaning we have a horizontal tangent line, clearly we have a relative max. So let's write our conclusion. At x equals 2 pi over 3, f of x has a relative max since, now again, you have to state two conditions that have to be true. Since f prime of x equals 0 and f double prime of x is less than 0. So we have a horizontal tangent line and we are concave down. Relative max. Let's go on to part B. Okay, part B says based on A, create a number line for f prime and then say where it's increasing or decreasing. Okay, so it turns out we are going to use a number line after all. So for f prime of x, we know what goes on our number line is our critical point of 2 pi over 3, where f prime equals 0. And now to create our number line, like I said before, we can't look in the front and see it's positive. That only works when we have polynomials like we've been doing before. So in order to figure out where this is positive and negative, by the way, notice that our limits are between 0 and pi, okay, from over here, so don't forget. Let's see, we have to take a test value in here and a test value in here and see whether f prime is positive or negative based on our test values. So let's make a note. So basically what we're saying is when you're creating a number line for non-polynomial functions, so for instance, logs, trig, or exponential functions, use test values to determine the signs. So let's pick a test value between 0 and 2 pi over 3. Something that is between those two. I'm going to choose pi over 2, which is 90 degrees, which for sure is less than 120. So I'll use pi over 2 and plug it into f prime, so I can see if this is positive or negative in this region. Cosine of pi over 2 is x over r, and x over r there is 0. So 2 times 0 is 0, plus 1 is just 1. That's positive, so that means between 0 and 2 pi over 3, f prime is positive, so f is increasing. Let's pick a test value now in this region and see. So between 120 and 180, maybe we could pick 120 to 180. Let's pick 150 degrees, which is 5 pi over 6. Or we could pick 135 degrees, which is 3 pi over 4. Either way, you're going to get the same sign. I'll go ahead with 135. So f prime of 3 pi over 4, which is again 135 degrees, so it's between 120 and 180, is 2 cosine of 3 pi over 4 plus 1. So 3 pi over 4 brings me to a 45-degree reference angle. Right here, it's -1, +1, radical 2. Cosine's x over r, so that's going to be 1 over radical 2. Cosine is x over r, so we have 2 times x is -1, r is radical 2, plus 1. This multiplies across -2 over root 2 plus 1. And now without a calculator, because this will be a non-calculator question, I need to figure out if this entire thing becomes positive or negative. I don't really care what the actual number is, I just want to know if it's positive or negative. So notice that the numerator here is bigger than the denominator, right? 2 is bigger than radical 2, which is like 1 point something. So that means I have -1 point something, let's say like -1.1, plus 1. That's definitely going to be a negative number. I have a negative something that's bigger than 1. Adding 1, it'll leave me with some negative decimal. So between 2 pi over 3 and pi then, in this region here, we're negative. Sorry, I don't know why that was shaded. So now let's answer the question. It said determine the increasing and decreasing intervals of f of x. Okay, I'm going to erase this note so we can fit in our answer. So using our number line and our test values, we could see that f of x is increasing where f prime was positive, so from 0 till 2 pi over 3. You need the explanation to get the second point, so we say since f prime of x is greater than 0. We can also say that f of x is decreasing on the interval from 2 pi over 3 to pi. Since f prime of x is less than 0, or the slopes are negative. So that's your points for the AP.